Imagine pressing a button and blasting off at the speed of light. Sounds incredible, right? Light travels at an astonishing 299,792 kilometers per second. That's fast enough to circle the Earth 7.5 times in just 1 second. Picture that for a moment. It's hard to comprehend such speed. But here's the catch. No object with mass can reach that speed. Yes, you heard that right. The laws of physics impose a strict limit. As you accelerate, things get complicated. Our friend Albert Einstein explained this. According to his theory of relativity, the closer you get to light speed, the more energy you need. It's not just a little more, it's a staggering amount. Imagine trying to fuel a rocket with endless power. That's what it would take to reach light speed. And here's the irony. The faster you go, the heavier you become. Not in a literal sense, but in terms of momentum. Your mass effectively increases. So you need even more energy to push through that barrier. It's a paradox, isn't it? You can't just keep accelerating forever. It's like trying to climb a hill that gets steeper the higher you go. Every attempt to reach that limit reveals more challenges. So what lies beyond that speed limit? That's where the mystery deepens. What if we could overcome it? That's a question that sparks the imagination. But for now, we're bound by these cosmic rules, and those rules are as fascinating as they are frustrating. Imagine trying to break a sound barrier. It's tough, but light speed is an entirely different beast. The challenge of reaching light speed isn't just about speed, it's about energy. Picture this. As you accelerate, your body feels heavier. But here's the twist. It's not your physical weight. It's your momentum that increases. So what does this mean in real terms? It means you need exponentially more energy to keep going faster. Think about it. Every push forward makes the next one harder. It's like running uphill with a backpack that keeps getting heavier. And this isn't just theory, it's backed by solid physics. Einstein's relativity tells us that you'd need infinite energy to reach light speed. Yes, infinite. That's because the laws of physics aren't just guidelines, they're hard limits. But why is that? As you near light speed, the energy required skyrockets. You could fuel a spaceship for years, but it wouldn't be enough. It's a cosmic game of tug of war, and light always wins. So what's the takeaway? Simply put, reaching light speed is impossible for anything with mass. It's a boundary we can't cross. And while that's a letdown, it also opens up fascinating questions. What if we could find a way around it? That's the hope that fuels our imaginations. Now let's dive into a wild concept. Time. What if I told you that if you traveled at 90% of light speed, time would actually slow down for you? It's true. Imagine boarding your spaceship, feeling the acceleration, and then watching the universe fly by. A journey that feels like just a few years could mean decades pass on Earth. When you finally return, everyone you knew could be older, maybe even unrecognizable. That's a shocking twist on what we think we know about time. But here's the thing. This isn't science fiction. It's a consequence of Einstein's theory of relativity. Let's consider an example. Think of identical twins. One stays on Earth while the other travels in a spaceship, moving close to the speed of light. After a few years, the traveling twin returns. To their surprise, they find their sibling has aged much more. This phenomenon is known as time dilation. It's mind-blowing, isn't it? You could live out your dreams in space while your loved ones age without you. But how does this happen? It's all about how speed affects the flow of time. The faster you move, the slower time ticks for you compared to someone at rest. It's a fundamental aspect of our universe. So, what does it mean for our understanding of reality? It challenges everything we think we know about time. It makes us question whether time is as linear as we believe. Are we merely passengers on a train that moves forward, or can we bend time in unimaginable ways? The idea that time is relative opens a door to endless possibilities. Now let's shift gears and explore a visual wonderland. Picture yourself zooming through space at incredible speeds. What would you see? It's not just a blur of stars, it's a dazzling spectacle. As you hurtle forward, stars ahead would appear brighter, shifting toward a vivid blue. But here's where it gets fascinating. Light from stars behind you would shift to red. This isn't just a pretty picture, it's a direct result of relativistic effects at play. The universe, with all its wonders, would warp around you. Imagine the cosmic tapestry unfolding before your eyes. Instead of a serene backdrop, you'd witness a dynamic, shifting panorama. Stars that once seemed distant would glow with intensity. Their colors would transform, revealing a beauty hidden from normal view. It's as if you're witnessing the universe in high definition, a breathtaking show that defies our everyday experiences. But why does this happen? The answer lies in the nature of light and how it travels through space. As you approach light speed, the wavelengths of light change. The blue shift occurs in front of you, making stars sparkle with energy. Behind you, the red shift tells a different story, hinting at the vast distances you're leaving behind. It's a sensory overload, a stunning reminder of how strange and magnificent our universe really is. This distortion isn't just an illusion, it's a fundamental aspect of relativity. The faster you go, the more stretched and warped reality becomes. It challenges our perception and makes us rethink what we know about space. What happens next is almost impossible to imagine. You aren't just traveling through space, you're experiencing a reality that's constantly transforming. Now, let's talk about the consequences of reaching light speed. Physics tells us it's impossible. Imagine needing infinite energy just to accelerate to that speed. That's the reality we face. So while it's thrilling to think about light speed travel, it remains squarely in the realm of science fiction. But why is this the case? To understand, we need to dive into the heart of physics. As you approach light speed, you don't just move faster, your mass effectively increases, making it harder to accelerate. The energy required skyrockets. Think about it. The faster you go, the more energy you need. It's a vicious cycle. This is why reaching that elusive light speed isn't just a challenge, it's an impossibility for anything with mass. But here's the kicker. Scientists do explore the idea of bending these rules. They dream of warp drives or wormholes. These concepts stretch our imagination, suggesting ways to bypass the light speed limit. But let's be clear, these ideas are purely theoretical. We don't have the technology to make them a reality. So, while we can ponder these thrilling possibilities, the truth remains stark. Achieving light speed isn't just a hurdle, it's a wall we can't break through with our current understanding. It's a fascinating paradox that keeps scientists up at night, wondering what lies beyond. Now, let's explore the tantalizing theories that suggest we might one day break through that wall. Imagine a warp drive that allows a spaceship to bend spacetime itself. Instead of racing through the cosmos, you could simply fold the universe around you. It sounds like science fiction, but scientists are seriously investigating this idea. What if we could manipulate the fabric of the universe? It's a thrilling thought. Then there are wormholes, shortcuts through space that could connect distant points in an instant. Picture traveling from one galaxy to another in the blink of an eye. But here's the catch. We have yet to find any evidence that these phenomena exist in reality. They remain hypothetical constructs, tantalizing us with their possibilities. But the fun doesn't stop there. Think about the implications if we could achieve these feats. We could explore the farthest reaches of the universe, witness cosmic events up close, and maybe even interact with extraterrestrial civilizations. The excitement is palpable. Just imagine the stories we could tell. But for now, these ideas linger in the realm of dreams. They push the boundaries of our understanding but are still far from our grasp. So, while we marvel at these concepts, we must accept that light speed remains an insurmountable challenge. Yet, it's this very quest for knowledge that fuels our exploration. The universe is vast, and who knows what discoveries await us in the future. The journey is just beginning.